Now we have security features of C and C++. C and C++ are very popular languages mainly because they are very powerful. However, many claims that the languages are comparatively unsafe. The reasons are pointers, buffer overflows, format string attacks. However, C++ has an advantage over C in regards to safety. Now let's see why pointers are insecure. The first one is memory leak, which we can describe here.
Imagine there are two pointers A and B pointing to two memory locations. In the program, the statement says that the A is equal to B. Now A is also pointed to the same memory location pointed by B. The memory location previously used by A is still allocated but not accessible. The other issue is dangling pointer. Dangling pointers are pointers that do not point to a valid object of the appropriate type. That we can simply say that these pointers are pointing to empty memory locations. Now we'll see that how this happens. Now let's say a pointer called A pointing to a memory location by using malloc function which is using in C. Then we use the free command without pointing the pointer at null. So now what happened is A is pointing to empty memory location. That was the issue of the dangling pointer. The other problem we have is the buffer overflow. Buffer overflow occurs when some input string is larger than the target buffer that we allocated for it. What happened is here is bytes on the stack above the buffer get overwritten. This gives advantage to an attacker to trigger a program that has high privileges. Now this diagram shows a situation of a buffer, and the red part shows the return address of the calling function. Now assume that the buffer overflow. Now see what happens. The return address has been overwritten. This code will show how the buffer overflow is implemented. Another problem in C is format string attacks. Format string attacks are possible if some formatting function like printf is incorrectly used. That is, if we use incorrect parameters. And that will allow to an attacker to read and to write on the stack. Another problem in C++ is underflow. Underflow happens when a new character is to be read at the get pointer, get ptr, but this has reached the end pointer, egptr, indicating that apparently no more characters are available in the internal input. Since that we have talked about the security problems in C and C++, we'll see what security features are available in the C and C++. So we have the access controlling feature that allows us the declaration of private and public variables. Also in C++ has implemented new functions that have replaced the old functions with the all shortcomings. String copy and string cat are potentially dangerous because they allow buffer overflowing. Generally, C++ is considered safer than C. The reason is C++ is an object-oriented language. Object orientation allows to enforce compile time security mechanism. So further Security features available in C and C++. Identify possible buffer overflow conditions at compilation time. No. Report buffer overflow exceptions at runtime. Buffer overflows are primary source of software vulnerabilities. Buffer overflow occurs when a date is written outside the boundaries of the memory allocated to a particular data structure. Buffer overflows are troublesome in that they can go undetected during the development and testing of software applications. Common C and C++ compiles neither. Code inspections have been used for many years to reduce errors in program development. Safe Secure SSCC. SSCC is a set of methods that eliminate vulnerabilities resulting from buffer overflows and other programming errors in C and C++. Using a mixture of compile time, link time and runtime test plus some design time restrictions. The basic premise underlying SSCC is that most exploits, especially those that transfer control to ability code, need to read or write to memory locations outside the bounds of the data structures defined by the program. This allows an attacker, for example, to override the return address on the stack or other addresses to which control is eventually transferred to execute arbitrarily code provided by the attacker or already resident on the system. By eliminating the possibility of such writers, it is possible to eliminate these vulnerabilities. Security features that are built into C++ compiler and linker. This compiler option, which is on by default, instructs the compiler to inject overrun direction code into functions that are at risk of being exploited. When an overrun is detected, execution is halted. This linker option, which is not enabled by default, instruct the linker to include the output image, a table containing the address of each exception handler. At runtime, the operating system uses this table to ensure that only legitimate exception handles are executed. This helps to prevent the execution of exception handlers introduced by a runtime hacker attack. This compiler option, which is not enabled by default, activates the code analysis that reports potential security issues such as buffer overrun, uninitialized memory, null pointer dereferencing, and memory leaks.